Okay, I'm going to start with a few examples. If for some reason you weren't in class and didn't hear the first part of this, please go back and watch the other video that leads up to these questions. So this is really the second part of 3.7. And in this we're going to take a look at a few examples, and the first one is going to start with describing the degree. So basically in this lesson we were deciding whether the degree was even or odd. So we're going to take a look at this number right here, and I know this is difficult, but we know that this is an even number, so it's an even degree function. The leading coefficient is 1, and it's positive. And that's going to have a big effect on the direction of this graph. The graph itself, if it's even and the leading coefficients are positive, will have opposite end behavior. So we might have a graph that looks a little bit like this right here. And so as we're going through this process of describing the end behavior, we use this kind of notation right here. And it looks a little scary, but it really, if you understand it, it's not too bad. So basically this is saying what's going on the left side of the x-axis, and this is the x-axis right here. What's going on the left, and this is the right. Okay, you got the star train in the background, so there you go. That's what I live with every night, folks, the star train going through my neighborhood. All right, so on the left, as we go up to the left-hand side of this graph is going up, okay, infinitely. So we would say that it's going to infinity, okay? And on the right-hand side, it's doing the same thing. So that's where we get these two answers for question number 1. All right, let's take a look at question number 2. And again, the first couple questions are not difficult. We're just taking a look at the degree of the equation, and it is 6, and 6 is an even number, so this is an even degree function. And the leading coefficient is negative this time, and that flips this graph over. So rather than the graph going up, we might have a graph looking a little bit more like this. Okay, so if we have a number line, the x-axis, as we go to the left, this graph is going down, so we would say negative infinity. And on the right-hand side of this is as x goes to positive infinity, the graph is also going to negative infinity. And so this is where these two answers come from. And that's basically what that question is asking. And so don't make it any more difficult than what it is. If you have to draw a sketch, then draw a sketch and get a good idea of what's going on. Let's take a look at question number 3. And you might want to try 3 and 4 on your own. Just pause the video and check your answers. So the leading coefficient, or excuse me, the degree of this equation is odd, and it's a negative leading coefficient because of this negative right here. So odd degree functions have opposite end behavior, and when the leading coefficient is negative, it's kind of like a line that has a negative slope. So y'all should be familiar with a slope. A line with a negative slope rises to the left and falls to the right. Now this might look a little bit more like this in reality, but you can see that it kind of emulates that of a line. So again, if we put our number line on here, let's draw it maybe right there, and we want to know what's going on on the left-hand side, the graph is going up, and on the right-hand side, the graph is going down. And so that's where these two answers come from. Notice that they're opposite of each other because it's an odd degree function. All right, question number 4. We have an odd degree function. Leading coefficient is positive. So this one is very similar to a line with a positive slope. Well, we should know that a line with a positive slope rises to the right. And so it might look a little bit more like this instead of a line, but nonetheless it's still emulating that same behavior that a line does, because a line is a first degree equation, which is an odd function. So again, this being the left-hand side of the graph and this being the right-hand side of the graph, on the left it's going down to negative infinity, and on the right it's going to positive infinity. All right? So this notation, in case I went too fast, all this is saying is as x goes to the left, or as x goes to negative infinity, f of x is going to negative infinity. And as x goes to positive infinity, or as it heads to the right, the graph is going up. All right. So that would be a couple examples that help you figure out that notation. Now, let's take a look at kind of going in the other direction. This time we're given the graph. Let's describe the end behavior this way. All right, so if we're looking at this graph, again, the left and right sides are both going up to positive infinity, which makes this an even degree function with the leading coefficient that's positive. So that's all that's asking you. And number 6, we have opposite end behavior. The left side's going up and the right side's going down. So again, as x goes to the left, the graph is going up. As x goes to the right, the graph is going down. So this makes it an odd degree function with the leading coefficient negative. All right, so the last two graphs were same thing. So again, you might want to try these on your own and then turn the video back on. So as we're looking, as x goes to negative infinity, in other words, as it goes this way, the graph is going down. And as x goes to positive infinity, the graph is going down. Okay? Since they're both doing the same thing, it's an even function with the leading coefficient being negative. All right, the next one, as x goes to negative infinity, or in other words, as you go to the left, the graph is going down. As you go to the right, the graph is going up. So therefore the degree is odd since it's opposite end behavior, and the leading coefficient is positive. All right, last few graphs you're matching here. So a couple of things you can do is look at the direction of the graph, the end behavior. Are they doing the same thing or opposite thing? So we can kind of look at question number 9 and notice that it is an even degree function. So guess what? Letter A is disqualified from that. The leading coefficient is positive, so both sides are going up. So it would have to be letter B, which means that number 10, we know and should know that it's a parabola. And then, which leads us to number 11, an odd degree function with a leading coefficient that's positive, is that right there. Okay, so the summary of this, as you can see from the summary, we have just several examples of the same thing, and there you go. That kind of looks like a smiley face. That one's leading coefficient is negative, it goes down. Right arm is up, right arm is down, right arm is up, right arm is down. So you can kind of remember that when you're figuring out that whenever leading coefficient is positive, the right arm is always up in both cases. All right. And that concludes this video. Hopefully it was helpful, and we'll see you in class.